There are two more special matrices that I want to discuss in this lesson as well, and the first one's called the identity matrix, and it's a special kind of diagonal matrix where we have only ones on the main diagonal. So for example, we could write down the 2 by 2 identity matrix, and it's a diagonal matrix that's 2 by 2 and has only the number ones on the main diagonal. We usually use the capital letter I to refer to an identity matrix, and sometimes you'll see me write a subscript beside the I, and this subscript here just tells us the size of the identity matrix. Do you think you could write down what the 3 by 3 identity matrix would look like? Here it is. And the other special matrix is called a zero matrix. The zero matrix doesn't have to be a square matrix. The only restriction on the zero matrix is that it contains all zeros. So we denote it with a capital O, and it can be any size we choose. So for example, here is a 2 by 2 zero matrix, and here is a 3 by 2 zero matrix. One of the nice uses of matrix multiplication is that we can use it to define powers of matrices. Specifically, what we're going to look at first are positive integer powers. So if we see a to the power of 1, that's really just the matrix A itself. If we see a squared, that means a times a cubed means a times a times a, and so on until we get to a to the power of k would be a times a times a, k times. Another thing that we have to worry about is a to the power of 0, and we define a to the power of 0 to be the identity matrix of size n. If we had this matrix A, we could calculate a squared by doing the multiplication a times a. And I'll let you check that when we do this multiplication, we get the matrix 1, 0, 0, 9. A cubed is really a squared times a, so we could do the multiplication 1, 0, 0, 9 times 1, 0, 0, minus 3. And once again, you should take the time to actually perform this multiplication. You should get 1, 0, 0, minus 27. As always, I have a couple of questions and notes for you at the end of this lesson. The first question that you may have thought of as we were working through was, what is the significance of these two special matrices we saw, the zero matrix and the identity matrix? Now, for the identity matrix, it's actually quite an interesting object. It's going to act like the number 1 when we perform multiplications for matrices. That is, if we have matrix A times an identity matrix, that's equal to A, or if we have identity matrix times A, this is equal to A. Now this comes with a little bit of a disclaimer, I'll put that up at the bottom, but this multiplication is only going to work if the sizes are compatible. And you may have guessed that the zero matrix is going to act like the number 0 for multiplication. So if we have A times the zero matrix, that's equal to the zero matrix. And if we have 0 matrix times A, this is also equal to the zero matrix. And once more, this comes with a little disclaimer that I'll put at the bottom. The sizes have to be compatible in order for us to do this multiplication. The second question you might ask as we're working through this particular lesson is, can we divide matrices? In one word, the answer is no. Do not try to divide matrices. In this course, we're not going to be dealing with that kind of operation. In other words, I never should see a matrix in the denominator of a fraction. Now, close to the end of our lesson, we talked about positive powers as well as the power of 0, and you might be wondering about negative powers. And I'm going to leave that for a future lesson. We will discuss that in, I think, 2 lessons from now. And the big note that I have for you is that you have to do lots of practice for multiplication. It's not a very easy operation to perform, so please take some time and make sure you fully understand the procedure for multiplication of matrices. All right, my little epsilons, stay positive.